Alright guys, here we go. We're going to do another lesson on types of correlations, and we are also going to learn how to fit a line to some data. We're going to do it by hand, and we're also going to show you a real fancy way to do it with your graphing calculators. So if you don't have your graphing calculators with you at this time, press pause, go grab it, and come back and let's do this. Okay, so here we go. Today we're going to first talk about three different types of correlation. The first type of correlation is a positive correlation. Okay, so that's just when we have a whole bunch of information and that information just kind of increases as we go along. So a positive correlation, that's when X increases and when Y increases. So it's two things increasing together. Now we have another type of correlation, which I'm sure you can guess would be negative. Now that's as X increases, Y decreases. So that would be a negative correlation. As X increases, Y decreases. And then the last one is actually just called no correlation. That means you just have information that is absolutely all over the place and you can't find any correlation whatsoever. So we can think of a whole bunch of different things for positive, negative correlations, and no correlations. An example of positive might be the longer you work out, the more calories you burn. We know that is a fact. An example of negative might be the more you brush your teeth, the less cavities you're going to have. And finally, no correlation would mean the blonder your hair, the better you'll do in Algebra 2 Trig, but the browner your hair, the better you'll do in geometry. Stuff that absolutely makes no sense whatsoever. So that's our types of correlations. And what we do is we use correlations to analyze data. And we could analyze data by hand, and sometimes it's a little bit tricky, not always very accurate. Once we get to the next page of the notes, we're going to show you a great way to do it with your calculator. So, fitting a line to data. You could try to sketch a line that's going to best represent this data by hand. And what you kind of want to do is you kind of just want to draw a line that looks like it's going to work. You want a little bit of information above it, a little information below it. You want to hit a few points along the middle. And this is only an estimation. Since this is Grand Am mileage, obviously we're not going to use any gas if we don't go travel any miles. And then you need to just try to find a point somewhere along that line that might work for us. So let's say after 2 gallons, that we used about 50 miles, or we went about 50 miles. Okay, so we're just going to use those 2 points. So we can take those 2 coordinates, 0, 0, and 2 gallons, 50 miles. And what we can do is we can just write a standard equation in point-slope form and convert it to slope-intercept form. We can find the slope. y2 minus y1 is going to give us 50 minus 0 over 2 minus 0, which we can tell is just 25. And that would be 25, obviously, miles per gallon. So that's our slope. To write the equation, we just have y minus y1 is equal to our slope times x minus x1. That'll just simplify to y is equal to 25x. And that's going to tell us that our Grand Am gets approximately 25 miles per gallon. Is that perfect? No, it's not perfect. We don't know. I mean, it could have been 24.8 miles to the gallon. This is just our rough sketch and trying to do it by hand. It's not very accurate. So what we're going to do is we're going to move on to the next page, and I'm going to show you how you can use that fancy calculator that you have, and we are going to do a little bit of data analysis with it. So here we go. We have this data represents the number of U.S. births from 2000 to 2007, where X is the years since 2000 and Y is in the thousands. So part A says to draw a scatter plot of the data. Well, you guys have probably done scatter plots before. What you're going to do is obviously you have your 0, and then you want to space out some tick marks over here. We've got 2001, 2002, 3, 4, 5, 6, 7. We don't need an 8 for this data, but we might for prediction purposes. And then what you need to do is you need to scale your y-axis. Now here's a little trick for you. You obviously are not going to go up by ones all the way to 4,158. Another thing is you probably don't want to even jump up by hundreds or something like that, because you want to look at your range. The lowest one is about 3,800 and the highest is about 4,200. So if we were to just start at 3,800 and then just kind of jump up in increments of 100. So we have 3,900. That's going to jump up to 4,000. This is going to jump up to 4,100, and then we'll finish at 4,200. And then what we can do is we can just do this little symbol. That says that we're skipping all the way, and then we're going to start at a higher number. Okay, so we skipped everything from 0 all the way up to 3,800, so it's going to look a little skewed, but that's okay. So then all you guys have to do is just take the information. So in 2000, there's 4,158. In 2001, there's 4,111, so it's a little bit above 4,100, and then 4,065 in year 2, so that's a little bit below. And then obviously you're just going to continue. 3 is 4,000. You get the idea. You just plot your points as you go, and you should see that it's almost aligned, but not quite. Especially since we're just sketching it, it's not going to look perfect either. And then we would try to draw a line, and again, this is not perfect. So we're going to use our calculator to do some math for us. So approximate the best fit for this information. So what you're going to do is you're going to go to your calculator, and we're going to teach you how to use a new feature. It's called linear regression. So here's a little part of the calculator you probably haven't used before. You see the stat button right here? Go ahead and press stat. And what that does is we're going to edit some lists. And I purposely have some information in here in case you do, because there's something that you never want to do, and that's delete a list. You want to clear a list. To do that, you scroll until you are sitting on top of L1. Do not press delete. If you do, you're going to have to see me tomorrow and let me fix it for you. And you press clear, and then you press down. And that will clear everything in list 1. Then you just scroll to the right, scroll back up to L2, press clear, press down, and that will clear everything in L2. Now, if you've never used list options yet in your calculator, you probably had nothing there. But if you have some information, that's how you get rid of it. Again, do not highlight a list and press delete, or it will go away. So in L1, we want to treat that as our X. So in L1, what you need to do is enter all of your information from X in our table, which is going to be 0. Just press enter, and it'll keep on going down for you. 1, enter, 2, enter, 3, enter, you get it. Keep on going until you get all the way to 7. Yes, I understand what you're thinking. The next one is going to be a little bit annoying. But we do have to enter all of this information as accurately as possible. So if you want, press the pause button so you don't have to listen to me the whole time. Or you know what? Why don't you just go ahead and enter all of your information for Y into L2. And we will meet back in just a second. And now you should have all of your information into L2. So this is what we're going to do from here. We are going to use our calculator, linear regression, to find us an equation that would represent this data. So what we're going to do is you are now going to go back and you're going to press stat. And this time you slide over to calc. And option 4 is lin reg. You want to slide down to option 4 or just press the number 4. Okay, and then now if you use L1 and L2, all you have to do is press enter, and the calculator is automatically going to do it. If you use something like L2 and L3, then you need to press some more specific buttons, so make sure you just use L1 and L2 when we're going to do linear regressions. If you need me to show you how to do it on, for more lists, then let me know and we'll go over that. So what you did is you see that the calculator says y is equal to ax plus b, where a is actually your slope and b is your y-intercept. So remember our classroom rule. What we are going to do is we are going to say y is equal to negative 41.464x plus 4141.75. All we did was we used our calculator, and as you can see, that's a lot more accurate than what we could have done if we would have done this by hand. Okay, so that is an equation that represents you know, the data here, how many births there are based on the years since 2000. So finally, part C says use the line of best fit to estimate the number of births in the year 2010. So remember, 2010 is 10 years since 2000. So all you need to do is take your calculator and you enter negative 41.464 times 10 plus 4141.75. We just use our calculator to do that for us. So a negative 41.464 parentheses 10, close your parentheses, plus 4141.75. You press enter, and in 2010 there were 3,727.11 thousands of births. Remember, this information says where y is in thousands. So this is, you know, over 1 million births in 2010. So that's how you use your calculator to get you a line of best fit and how you would use the information. So the very last part of this lesson is linear interpolation and linear extrapolation. Linear interpolation simply says that you predicted inside the domain. Extrapolation means that you predict outside the domain. And how did you do that? Well, you just look at your given data. We did 2000 to 2007. So if we were predicting something in between 2000 and 2007, that would be interpolation. But since we did 2010, which is outside of our given data, then that would be extrapolation. Have a good one.